This video looks at Redox 1, the determination of the iron content in lawn sand, a practical that is frequently done at rugby school. In a previous video, we have looked at the standardization of the potassium manganate 7 solution using a standard solution of iron 2 sulfate. We now have potassium manganate 7 of a known concentration, and we are going to use it to analyse the iron content in the lawn sand. The lawn sand can be bought at a garden centre and contains sand and some iron 2 sulfate, and we're going to titrate it with the manganate 7 and convert it into iron 3. In order to do this quantitatively, we are going to measure out a certain mass of the lawn sand and transfer it to a volumetric flask. The volumetric flask is a 250 cm3, 250 ml volumetric flask. It has previously been cleaned with distilled water. Because the titration requires acidic conditions to make sure the conversion of manganate 7 from its purple colour to the near colourless manganese 2 iron, we are able to add dilute sulfuric acid as we make up the solution in the volumetric flask. The instructions ask for approximately 9.8 grams of the lawn sand to be weighed out. But the value that is put into the volumetric flask has to be known accurately. For this reason, we're going to use a piece of paper. We're going to put the lawn sand onto the paper, transfer to a small beaker, and we're then going to reweigh the paper so that we know the exact mass of the lawn sand that has been placed in the volumetric. So, making sure that the balance is at 0, we put the paper on and we roughly notice that it weighs just over a gram, so we're looking at adding around about 10 grams to it, so around about 11 grams we're looking for. We must be careful not to drop any of this onto the balance, but make sure it's on the paper. So this is the lawn sand. It's being transferred, and I'm looking for around about 11 grams. It doesn't really matter whether it's a little higher or a little lower. We are given the instructions of 9.8 grams, but it needs to be somewhere in that region so that the tighter values are reasonable. So at the moment we're up to about 9.23. So we're looking for around about the 11 mark. A little bit more. That would seem to be a reasonable amount. 10.89 is the mass of the paper and the sorry, let's leave it for just a second more. $10.89. Okay, so at 10.89 we must make sure that we transfer all of this into the beaker. The beaker also could have been cleaned with distilled water. So we're trying to transfer all of it. It doesn't matter if some of it remains stuck to the paper, because we're going to place the paper back. Oops, there is too much there, I think. We'll just leave that off. We place the paper back onto the balance. And you can see that that weighs 1.17 grams. 1.17 grams is the mass that we have of lawn sand in this particular example. We're then going to make up a solution. So to make up the solution, we are going to add distilled water and the sulfuric acid, and we're going to do this in a small beaker so that we, in part, make sure that we don't exceed the 250 cm3 limit that we have on this solution. We're going to fill the solution to the bottom of the meniscus to this brown line, and that gives us exactly 250 cm3. Of course, as soon as we introduce the glass rod, we have the potential for putting some of the lawn sand onto the glass rod, and of course there's plenty of the lawn sand making contact with the inside of the beaker. So both must be considered when we work these solutions. If we add just a little bit of sulfuric acid at this stage, and we try to get the lawn sand to dissolve as much as we possibly can with this quantity. Now, of course, this is nowhere near 250 cm cube. If you were to exceed the 250 cm cube mark, you would have to start again. So we continue to work that, just a little bit more sulfuric acid, taking up to about 1/5 of the volume that we've got. Its solubility appears to be better in sulfuric acid, perhaps, than in distilled water. So when we come to transfer this, ideally at this point we would have a solution and there would be no residual undissolved lawn sand, and you can continue with this for some time to ensure that that is the case. This quantity of lawn sand will dissolve with a bit of work in this relatively small volume of water. So you continue to work on that. Now, one good technique for making sure that the glass rod doesn't drip with the solution which you're transferring is to place the glass rod very carefully down the neck of the volumetric flask and then pour the solution down the glass rod, rotating slightly so that the glass rod is in effect cleaned. As you take out the glass rod, similarly you must be very careful to make sure that no drips go anywhere other than back into the beaker. Now, the beaker may or may not have residual lawn sand in it, but we must make sure that we rinse any of that into the volumetric flask. So again, we will work this, and at this stage this is looking very clear, and it doesn't look as if there is any undissolved undissolved lawn sand in this particular beaker. There might be some still in the volumetric, but we can work on that in a second. So we pour again, and again that's rinsing the glass rod of any lawn sand, and we might do this 2 or 3 times possibly, keeping an eye on the volume, of course, because it mustn't exceed that 250 mark. So we place that back into there. One more with the glass rod, small quantity there. We'll clean the glass rod for the last time, place it down there, and we pour down the glass rod, keeping an eye on that solution. Okay, so now the glass rod, we could use a little bit of distilled water just to run down the glass rod. And that glass rod now is pretty clean, so it can be placed away. We're still needing to keep rinsing the beaker though. So rinse the sides down, and pour the solution into the volumetric flask. And of course there may not be any solution. Keeping an eye all the time on the volume that you're using, and also on the idea that if you go beyond the 250 mark, you will of course have to start again. And the reason for that is that you then are unaware of the volume that is there. It's something over 250. And so you would have to do it again. You can't just simply discard some of it, because some of it would be, of course, our lawn sand. So I think we've probably worked the beaker hard enough now. We've washed it several times and we're getting near the end. So as we head towards the end, we could potentially add some more sulfuric acid, or we might simply top this up now with distilled water. Now, at the moment that you get close to the end with the distilled water, depending on your skill levels, you might choose to just keep on dripping till you get the bottom of the meniscus. Or alternatively, you could always, right at the end, decide to change to a teat pipette technique where you're in more control of the teat pipette. And so you can just add it drop by drop so that the bottom of the meniscus, get your eyes at the same level, the bottom of the meniscus is on the brown mark, which is about there. Okay, at this point, you should stop at the flask, and then you must make sure that everything is dissolved and that it is homogeneous. Now you do this by turning it upside down and shaking. This ensures that there is no build-up, a local build-up of high concentration of the lawn sand in one area. When you come to pipette, it's also a good technique to make sure you do a few more inversions to make sure that the solution is totally homogeneous. So from this point here, we have a solution of lawn sand which contains 9.8 grams in that 250 cm cubed. We're then going to pipette 25 cm cubed of this solution, add 25 cm cubed of the sulfuric acid to ensure acidity, and we're going to titrate it against the standardized potassium manganate 7 that we saw in the last video.